So yesterday and Tuesday we learned how to divide using models. Sometimes we were able to fit everything evenly in our models. Sometimes we had leftovers. What were the leftovers called? Mason? A remainder. Well, today we're going to start learning how to do it without using the models. The paper and pencil way. Sometimes we call this the algorithmic way. It's just a fancy word that means working it out with paper and pencil. Quickly, Victoria. Okay, so before we begin, imagine that I have 23 Post-its. So imagine it. Picture it. I have 23 Post-its. I want to give them to 5 of you evenly. That means I want to give the same amount to each of those 5 people. Kingston, I want to give you an equal amount. Victoria, I want to give you an equal amount. Smith, I want to give you an equal amount. Cullen, I want to give you an equal amount. And Zadie, I want to give you an equal amount. But I only have 23 to give. So, I have to figure out, okay, I have 23 cards, I have 5 kids. I want to give them to each of them, but I want them to have the same amount. What division problem does that look like? Mason? 23, the number of cards, the number of Post-its, divided by 5, the number of kids. So let's imagine that each of these boxes, because I can't actually give them to you, are the kids. This one is Kingston. This one is Smith. This one is Zadie. This one is Cullen. And this one is Victoria. Now I have those 23 Post-its. Imagine I'm actually handing these to you. How many am I going to hand to you at a time if I don't know exactly how many to give you? Carla.
We will have to regroup the 2 tens.
Okay, listen to the question. That's not the question I asked, Carla. If I didn't know exactly how many to give each of these kids, and they're all standing in front of me, how many would I give each of them at a time so that I can make sure they all got the same amount? I didn't give too many to one kid or not enough to another. Zari.
We will do 1 by 1.
I would give them to you 1 by 1. I would give 1 to Victoria. Then I'd give 1 to Kingston. Then I'd give 1 to Smith. Then I'd give 1 to Zadie. Then I'd give 1 to Cullen. But I've only given away 5. How many am I supposed to give away? Class?
23.
23. So I'm going to keep going 1 at a time until I don't have enough to go around again, right? So I've got 5, 6, 7, 8, 9, 10. I know I still have enough to go around at least one more time. I have a lot more than 5 left. 11, 12, 13, 14, 15. I started with 23. I've given 15 away so far. I know I have more than 5 left. 16, 17, 18, 19, 20. I've given away 20. I started with 23. I need to mentally think, How many cards are left? How many Post-it notes are left? Is that enough to go around again? I gave away 20. I started with 23. I have 5 kids to give them to. Mentally think, do I have enough to give each kid another one? Ethan? No, because I only have how many left? 3. I only have 3 left. Is that enough to give to 5 kids evenly? No, that's only enough to give to 3 kids, which means 2 kids have less. And do I want anybody to have less than anybody else in this case? No, we need them for something. You have to have the same amount for whatever reason that we need it. So that means my answer is how many Post-its each gets with some leftovers. So what does my answer, my quotient, look like? I started with 23 Post-its. I gave them evenly to 5 kids. So each kid got how many? And is that all we need? Michaela, how many Post-its did each kid get? 4. Is that my final answer, Michaela? No, because what did I forget about? My leftovers. How many do I have left over? Which means my remainder is what? 3. How do I show that in my answer? I write capital R, and then I write 3. So that means 23 divided by 5 is what, class? Class?
4 remainder 3.
4 remainder 3. So that was just modeling. Can I always use my 10 rods when I'm modeling? Like, this would look like 2 10 rods and 3 1s cubes. But was I able to use my 10 rods? Was I able to use my 10 rods as 10 rods? What did I have to do to them in order to split them evenly? Can I split 2 10 rods between 5 kids? If I have 2 10 rods, can I give each of the 5 kids a 10 rod? No, I don't have enough. So what did I have to do with my 10 rods? You can tell me the non-math way, the non-math word. Smith, what did I have to do with my 10 rods?
You turn them into 21 cubes.
I turn them into 21s cubes, or 20 Post-its. What is the math word for that? For taking my 2 10 rods and turning them into 21s cubes. What's the math word for that? Aaron? Regrouped. I regrouped. Well, that took a long time, didn't it? I mean, not that long, but longer than it could take. So we're going to learn a shorter way to do it. We have all the same steps. It just doesn't take as long because we don't have to draw pictures. So, don't be scared. We're doing all the same steps, just in a different way. What I want you to do, you don't know why you're writing this yet, but it will help. In this blank space, yeah, you guys have a blank space. I want you to write what I'm about to write. We're going to write the steps using only one word. I'll tell you what they are, because you don't know what they are yet. We haven't gone through example 1. Step 1, divide. Step 2, multiply. Step 3, subtract. Step 4, bring down. Step 5, divide. Step 6, multiply. I bet you know what's going to come next. Who thinks they know what step 7 is? Kingston. Correct. Step 7. Subtract. Now this is where it changes a little sometimes. Today's lesson, step 8 is you're done. Other lessons, it will be bring down, and then we'll do it again. But we'll see those later. Today's lesson, these are the 8 steps. Now you may be like, what? Okay, I know all those words. I know how to do most of those things, but how do I put them all together? Well, we're going to see that today. And we're going to check them off as we go. Okay? So everybody, finger or pencil on example 1. I know there's a sentence up at the top under the title, but it's common sense. We don't really need to read it. It just says, you have used models and fact families to divide. Models we did yesterday and Tuesday. Fact families, that's when we knew the basic division fact. And we use basic division facts and patterns to solve. Well, today, we're going to add in some place value. With division, do we start with the ones place? Smith?
No.
No. Where do we start? Colin.
With the highest.
Sorry. Thank you, bud. Colin.
With the highest digit.
Not the highest digit. You're close.
The highest place.
The highest place, or the greatest place value. There you go. Because remember, digits and place are different. So in division, you start with the greatest place value. Today's lesson is only going to have tens. We're not going to stick with just tens for this whole chapter. But today's lesson, we're just going up to the tens place. We're not going past the tens place. The divisor will always have one digit. The name of this chapter is dividing by one-digit numbers. So that means this whole chapter, we will never have more than one digit in our divisor. However, in our dividend, I think we go up to 4 digits, which is not hard. You just do these steps another 1 or 2 times, depending on how many digits. You do. Do you see how there's a group? And then there's another group? You do this group of steps for each digit, for each place. Okay? So once you know the steps, it's really not so bad. And then you just repeat when you're done with the place. So everybody, finger or pencil on example 1. Do not stress. I promise you. By tomorrow afternoon, you will have this. Some of you will have it today. Some of you will have it halfway through the lesson tomorrow. Or no, some of you will have it today. Some of you will have it tonight. Some of you will have it tomorrow morning. Some of you will have it halfway through the lesson tomorrow. The rest of you will have it by the end of the lesson tomorrow, I promise. As long as you're listening, focusing, and paying attention. Because these are the only steps we're doing. We just have to repeat them as many times as there are places. We're only going to be repeating them once today because we're only going to have 2 places to look at. So, one more time, finger or pencil on example 1. Make sure your heads are up and you are listening and focusing and not stressing out because it's okay if you don't know how to do it. It's okay if it looks a little scary. We haven't done it yet, but it won't look scary by tomorrow afternoon. Read in your head while I read out loud. Nolan and his family went to a water park during their vacation. Each seat on a water ride can hold 2 people. There are 39 people. How many seats will be needed? So, let's go through this problem just like we always do. First, we're going to underline the question. The question is, or the command, because is it always a question? Sometimes it ends with a period, but it's telling you what to do, so it's a command. In this case, we do have a question. How many seats will be needed? Do we see the word about in that question? So are we estimating today? No, we're finding actual answers. But we do see what we always see. We see a noun after the words how many, or words that mean the same thing as how many, like what is the number of. We see the noun seats. So we know seats is our answer unit. Now sometimes in our division question we can see each with the other unit. In this question we don't. But I'm sure we'll find it somewhere else in the question. Some of you will be like, I know where it is. But let's go step by step. We found everything we know we need in the question. So let's go back to the beginning. Nolan and his family went to a water park during their vacation. Is that important to this problem? Is that important to solving the problem? No, it just tells us, hey, this is what's happening. Each seat on a water ride can hold 2 people. Well, we see the word each, which means we're multiplying or dividing. But, usually I know to look for my other unit, I look at the word after each. But I don't see the word each. I mean, I don't see a different word. I see seats, which already knows my answer unit. My answer unit and my other unit can't always be the same. So, let's keep reading. Each seat on a water ride can hold 2 people. Well, it's like that question with the entrances and the lines. If each seat can hold 2 people, what does that mean the other part of our equation is? We know the seats are going to be part of our equation somewhere. But what else do we know? Sorry?
2 people.
2 people are what the seats can hold. So, okay, we know we're probably going to have to use that because we know we have people, and we know we have to figure out how many seats. We know 2 people can fit on each seat. Then it says there are 39 people. I still don't see I don't see a number with our answer unit. But that's okay. Sometimes in division that happens. In division, sometimes the units in your equation are the same. Because I know if there are 39 total people and 2 people fit on each seat, and I'm trying to figure out how many seats there are, that means I'm taking those 39 people and I'm breaking them down into groups of 2 to figure out how many groups of 2 I have. Okay, so this is the opposite of where we know the groups and we're putting items in the group. This time we know the total and we know the number of items in each group. That can happen in division. Remember, because I said sometimes the divisor is the number of groups, sometimes the divisor is the number of items in each group. If the divisor is the number of groups, that means the answer is how many items are in each group, like what we did in the lesson yesterday. But if the divisor is the number of items in each group, then the answer is the number of groups. Please make sure you're paying attention. Some of you are tuning me out, and this is going to be really hard to find the pieces. So in this case, we know the total number of people. We know we're starting with 39 people. We know we're breaking them off into groups of 2. We're taking 2 people here, 2 people here, 2 people here, 2 people here, until we're done with all the people. So we have to figure out, okay, we're taking 2 people and putting them in groups. And then we just have to figure out, okay, how many groups are there? And that will be our quotient. So imagine a seat on a ride. 2 people can fit on each one. I'm not going to draw them all because that would take forever, and we're not modeling in this lesson. But just picture it. We know there's going to be 2 people in each group. We just have to figure out how many groups there are. Seat is kind of like a group. It's kind of, we can picture it as like these. We already have the groups. We're just going to put people on each of them. So that means we need to take the 39 people and divide them, because if we start with 39 people, are we going to end with more than 39? No. If we have 39 people and we know 2 people go in each one, are we going to need more than 39 seats? No. So we know we're dividing. We're taking the amount of people and we're breaking them down into groups of 2. So our equation is 39 divided by 2 will equal a certain amount of seats. So, I want to leave those steps there. Remember what I said about division with brackets. What goes inside the bracket? Which piece of the division problem goes inside the bracket? Victoria. The dividend, the largest number. We know our dividend is 39. So we have 39 inside our bracket. What goes outside of the bracket? Which piece goes outside of the bracket? Smith.
The divisor.
The divisor. It goes to the left, not on top. And on top, ignore what's there because we don't know that yet. What goes on top of the bracket? Cullen.
The quotient.
The quotient. So let's look at our steps. Step 1, divide the tens. We know we start with the greatest place value. Think about it. How many times will 2 fit into 3 without going over? If I have 3 baskets and we'll say 3 boxes and 2 apples. How many times can I put them in those boxes without going over? Doesn't matter if there's some left over. How many times can I put 2 into 3 without going over? It doesn't matter if there's empty boxes. It does matter if I put them in and there's leftovers. There's some outside. How many times can these 2 apples go into these without going over? Michaela? Once. I can fit them in once. If I try to fit them again, what happened? I went over. That means I don't have the same amount over here. So, there are 2 groups of, there's 1 group of 10 inside 3 tens. Just imagine. Ignore this group of 10. It confuses. How many times does 2 go into 3? Only once. Because if I did it again, 2 groups of 2 is 4 in all. Right? 4 is greater than 3. If I have 2 groups of 2, I have 1, 2, 3, 4. 4 is greater than 3. So I can't do that. So 2 goes into 3 one time. Now, I'm going to multiply. I'm going to take the number I just got, which is 1. This is brand new. I just got it. And I'm going to multiply it by your divisor. 1 times 2 is what, class? 2. 2.
Ew.
I'm going to put it right underneath the place that I'm dividing. I'm dividing the tens place right now, right? I figured out that 2 will go into 3 one time without going over. Then I multiply. 1 times our divisor is 2. So I divided to get 1. And now I've multiplied to get this 2. What's the next step? Class, what's the next step?
Subtract.
Subtract. So all I'm going to do is say 3 minus 2. What is 3 minus 2, class?
1.
1. So I multiplied. 2 times 1 is 2. 1 times 2 is 2. Then I subtracted. 3 minus 2 is 1. And the reason they're saying compare is because this number, just like what we learned, can never be greater. What we get when we subtract can never be greater than our divisor. Is 1 greater than, less than, or equal to 2? Zadie? Less than, so we're good. That means we didn't put not enough in our groups. Okay? It's like when we model this, we know that these 3 is less than our divisor 5. So that means we can't go around again. We can't put them in the groups evenly again. So we just subtracted. What's the next step? Class,
Divide.
what's the next step, class?
Bring down.
Bring down. All that means is bring down the next place. Bring down the digit that's in the next place. We use this 3. We're done with it. So what's left? What do we have to bring down next? What digit do we have to bring down next, Michaela? 9. So we are actually going to draw an arrow every single time and bring it down. How many do I have now? I used to have 9, but now I have how many? What's my new number? Smith.
19.
19. So there are now 19. So we divided, we multiplied, we subtracted, we brought down. What do we do next? Class, what's the next step? Divide. So we do the same thing again, but instead of looking up here, we're ignored. We are done with this number right here. We're only looking at this new number that we just made. So when we get to this step, we only look at the number we just made. So now we're trying to figure out, okay, how many times will 2 fit into 19 without going over? So 2 times what will get us something close to 19 that is not bigger. Doesn't have to be exactly 19, but it has to be something close that is not bigger. So we know we can multiply something by 2 to get 20, but we can't put that because 20 is greater than 19, right? So we have to figure out, okay, is there anything I can multiply 2 by to get 19? Class? No. 19 is not a multiple of 2. We know it can't be 20 because that's bigger. So we have to think, okay, what's less than 19? That's close and is a multiple of 2. Zari?
18.
18. Well, so that means 2 times what will equal 18? Zari?
2 times 9.
9. So that means 2 can fit into 19 9 times without going over. So our next answer goes above the digit in the ones place. 2 can go into 19 9 times, bless you, without going over. So we just divided again. There are 9 groups of 2 in 19. Because we know if we take 19, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. We can make 1 group of 2, 2 groups of 2, 3 groups of 2, 4 groups of 2, 5 groups of 2, 6 groups of 2, 7 groups of 2, 8 groups of 2, 9 groups of 2. Can we make another group of 2? No, because we only have 1 left. But we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So that means 2 can go into 19 9 times without going over. So we just divided. What do we have to do next, class? What's the next step?
Multiply.
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 So, everybody listen. We're not going to do 19 times 2. We are just going to take the digit we just got, which is what? What is the one digit that we just got by saying how many times 2 will go into 19? What is that one digit? Mason? 9. So we are only going to multiply that 9 by 2. Not the 19 by 2, just the 9. 9 times 2 is what? Class,
18.
18. Just like we did before, we're going to take that 18 and we're going to put it right underneath the number we had before. We're lining it up. The ones go beneath the ones, the tens go beneath the tens. So we just multiplied. What's the next step? Class?
Subtract.
Subtract. So again,
Subtract.
we're just going to subtract. 19 minus 18 is what?
1.
Class?
1.
1.
1.
So we know we multiplied 9 times 2, which is 18. We subtracted 19 minus 18, which is 1. And now we're going to compare. We just subtracted. Let's compare, because remember, we're trying to make sure our answer to that subtraction problem is less than our divisor. If it's equal to or greater than, we did something wrong. We have to go back a step or two. Is 1 greater than, less than, or equal to 2? Cullen?
Less.
Less than. So are we good?
Yes.
Yes. What's the next step? We just subtracted. We did our little comparing. What's the next step, class?
You're done.
You're done.
You're done. Because we can also tell, because do we have anything else to bring down? No. If we have nothing else to bring down, we're done. We don't have anything else. We also know we're only working with 2-digit numbers, so we're only going to do these steps twice. So what that means is that we have 19 groups of 2 in 39. If I drew 39 dots, 39 people, I could break them into 19 groups of 2 with 1 person left over. So that means the answer, 39 divided by 2, the remainder moves up, is 19 remainder 1. Which means that 19 seats are full, and there's 1 extra person on an extra seat. On rides, are you allowed to ride 1 person per seat? You're not? If you've been on a ride, has there ever been a point where there's less people in a row than there are actual spaces? Yeah. You don't have to completely fill it. So that means, does that 1 person get kicked off? They can't ride just because they don't have somebody to sit with? No, they just get a seat to themselves. So we have 19 full seats and 1 extra person sitting on a seat by themselves. How many total seats is that? There's 19 full seats, 1 person sitting by themselves on an extra seat. How many seats is that? Kingston? Come on, try it. You had an answer. Try it. Why do you think never mind? Because you're right. 19 seats are full. Here's our 19 full seats. 1 seat only has 1 person. But that person still needs a seat, right? So 19 full seats plus 1 half full seats is how many total seats? Michaela? 20. So 20 seats are needed. But the important part to this question is this. Okay, we're just going to finish that tomorrow because it's time for reading. Some of you are stressing. Some of you tune me out because you're like, oh, sorry, library. Some of you are stressing out because you stopped listening halfway through. And you're like, I don't get it. So you just stopped listening. Sit up. I'm really, really frustrated when people think, this is too hard. Zoning out now. Shutting down. It's too hard. I'm not going to be able to do it. I don't care anymore. With that attitude, what is going to happen? If you have that attitude, it's too hard, I don't know how to do it, I'm not going to be able to do it. I'm done. I'm going to my happy place. What is going to happen with that attitude? Mason, you're not going to be able to do it. But if you think, I'm a little confused, but I know we're not done yet, so I'll keep going. I know we'll practice more. What's going to happen? If you have an attitude, I'm a little confused, but I know we're going to do more practice, what's going to happen? Victoria?
You're gonna probably get most of it right, or maybe all of it.
You're going to get there. I know this may seem confusing. Some of you, like I said, may be like, okay, I got this. This isn't so bad. I need more practice, but I think I got it. Some of you may be like, I'm not there yet, but I know if I have more practice, I'll get there. Some of you may be like, I'm really confused. I need a lot more practice. Well, guess what we're going to do tomorrow? Class. A lot more practice. I'm going to give you 2 problems to try out tonight.
Because she usually.
Sorry. I'm going to give you 2 more problems to try out tonight. I just want you to try these steps. You have them written. I want you to try following them on the problems I'm going to give you tonight. You've already seen the problems. Not here, because you're not going to copy. Because if I gave you this problem, 39 divided by 2, then you could just copy this and be like, I got it. But did you? No, you just copied it. But you have seen the problems before. Hint, hint. Where's my head pointing to, class, for the girls at home who can't see where my head is pointing? Tell them.
You're pointing to the homework.
I'm indicating the homework board. When I say you've seen these problems before, so you know what the right answer should be. But I want to see you trying this setup to get there. Please, don't let your parents do it for you. I will tell you right now, you will get a grade for doing it. You will get a grade for not doing it. So what does that mean? What happens if you turn it in and you try?
I don't know.
Victoria.
If you try, you will probably get a good grade. And if you do not try and you ask your parents to play and you check in the book, then you would probably get a low grade.
Yes. If you turn it in and you try, even if your answer is wrong, you'll still get a good grade. If you don't turn it in at all, well, you'll get a 0. If you turn it in, but I can tell you didn't try because you literally wrote this and like the answer that you know it's supposed to be because you have it on your piece of paper, you're not going to get a good grade. If you turn it in like this and I don't see at least some of what needs to be there, like I can tell you just kind of wrote random numbers and like put them in random places, you won't get a good grade. But if you try, go one step at a time. Do not think ahead. Go one step at a time. What I mean is when you are on the division step, don't be thinking about, oh my gosh, what do I do when I get to the subtraction step? That's what I mean. Keep your brain on the step you're at. Don't be thinking about multiplying when you're just still dividing. You're thinking about how many groups of this divisor will fit into each place. We know 2 will fit into 3 one time. Because if I have 2 times, how many do I have in all? Class?
4.
4.
Will 4 fit into 3? If I have 4 apples, are they going to fit into 3 one at a time? No. I would have my 3 boxes filled and then I'd have that extra apple. Also, look what happens if I do that. 2 goes into 3, 2 times. Now I have to multiply. The number I just got, 2 times 2 is 4. Now I have to subtract. Uh-oh. Can I do 3 minus 4? If I have 3, can I give 4 away? No, I don't have enough. So if you get here and you can't do the subtraction because what you're trying to subtract is bigger than what you started with, you said it, you put too many up here. Okay? So watch out for those mistakes. We are going to have a lot more practice tomorrow. This happens almost every year. So don't be stressed. Okay, so for right now, go ahead and close your math books. Put them away. I don't think you need anything for reading today, so we'll just leave it. Stand up, push your chairs in. Make sure pencils are in the groove on top of your desk or in the opening of your desk, not just sitting on your desk. Girls at home, you can go